Good morning, good afternoon, wherever you are. Welcome back. This is Liam Recorder, cybersecurity instructor for WazU. Today we're covering the last workshop for the system admin class that began a couple weeks back. We've already covered the first 7 lessons in our system admin course, and we have the last 3 to cover today, and they're actually kind of on the wind down. Most of you I know have already gotten well past sort of uh, more technical exercises, including some VM and cloud exercises earlier, and then the shell scripting last week. Seems that most of you did pretty well with that. I'm a little behind on grading, but we'll get caught up here soon. But nonetheless, we have the last 3 lessons to cover today. And the first one we're going to cover is lesson 8, which is on secure network and systems design. One of the things that I like to start with is that we have 2 pieces there, right? Secure network design, which of course is a distinct piece. What are we going to do where are we going to put firewalls? Where are we going to put intrusion detection? How are we going to think about the network design from a security point of view? And then we have this broader system design. And of course, system is very much, it technically could be one system, one computer system, one major server, for example. And of course, it could be a larger system like a series of geographically distributed data centers, or a combination, a hybrid model of deploying whatever our application, our system is out in the cloud. And so that's a grayer, more nebulous piece as to what we mean by system. But one of the things that, in effect, they all share is that we should be sort of one of the best practices, common things, and this even applies, we're going to talk about in the last lesson, and is actually one of the problems right now when it comes to how some of the embedded Internet of Things, or IoT systems, are being built, at least the majority, is that they're not designing security in from the beginning. That security is not a default feature. It's kind of a bolt-on, if at all, later in the process. And so it's sort of the number one guiding principle of, how do we do secure network or system design? We want to be taking security. We want to go all the way back to that first class, those very basic principles: defense in depth, diversity, limiting, all of these principles that guide us. When we go in to apply them now, we're going to use those to help us decide where we're going to place things, what kinds of, policies and procedures we're going to put in place to protect our systems and protect our networks. There is a number of different, in the first part, in the network architecture part, or the network design part, there's a whole bunch of best practices. As usual, I'll leave you to read those on your own. As I did say in the beginning of this class, this is one class that is full of a lot of best practices, because it is this overview of system admin for our cybersecurity program. But there is a good example in there, and it's one to take a look at, because the exercise, in a sense, builds off of that kind of example. But there's an example of sort of a secure network design, if I remember right, particularly around kind of a web, kind of application, protecting web servers and the DMZ. And then you're going to have, as an exercise, and I believe it's in this lesson, you have where you're given a diagram, and your job is to kind of use what you've been learning through these courses in this course and decide, what types of things need to go into different places on the network. So, take a look at that one and get sort of the basic principles of, where are certain elements being placed, and pay attention to that. That'll help you in that exercise. As I said, the system design is the one that gets broader, because it could apply if you're setting up a web server. That's a system. And if it's really critical to your business, it's probably more than just one, machine. It's probably a series of machines and cached, content delivery network partners, possibly multiple, versions of the site, or even set up in different parts of the world. If you're a global company, you want responsiveness all over, so you may have your site hosted at multiple places or in multiple clouds, regional environments around the world for speed. And so here's a website that, okay, you think, well, that doesn't seem all that complex, and now all of a sudden it did, right? We now have, say we have a half a dozen, basically instances of our web server in different geographic regions, not geologic time, sorry, geographic regions. And so we, of course, then, we have that what is all that? Well, that may be more than even one instance itself. It may be the web server instance. If we've just spun up, say, a container, maybe we have spun up a more full VM and we're running everything we need on that, the web server, the database, any backend framework we need. Or maybe we've done it containers. So we have the web container, the database container, some authentication, and another container. So at each instance now we're spinning up multiple things. And so this one web server can be a very complex system. And so, but in all cases, once again, we want to start by, thinking in the very beginning, what do we want to do? What are our, do our usual risk analysis, apply our usual concepts and principles to decide how we would design that system from a secure point of view. Obviously, there's going to be certain points as we think through what's going to happen and how the application is going to run. Obviously, people are going to come in with their browser and hit our website, and then that is going to have to pull data from the database, and it's going to have to deliver that back. And if we're running those on separate instances, then they have to be able to communicate with each other securely, but we want to lock down other people's ability. If that's the model, then what you'll see is a very common model if we're splitting, say, the web from the database, is that the web will be set up to be, obviously we're going to be publicly accessible here so people can hit our website, but then the web server, has some kind of dedicated connection, maybe through firewalling and any other types of means, so that basically, even though that database server is out there on the net too, in a sense, it's been locked down so that people can't just come in directly to it. It's only going to allow a communication from that web server. That's a smart move. We don't necessarily need other people pounding away on our database in the background trying to break in, so we can just block all that. We could have just a few whitelisted IPs that are going to be our servers, our web, the front end pieces. We could, of course, whitelist some administrative stations or IP addresses so that obviously text could get in. We're going to probably use, obviously, for any kind of remote access to these instances or VMs, we're going to use SSH and private keys and public-private key setups. And so we're going to have to think all that through. How is it going to be managed? How does it integrate with our existing systems? And then, make sure that we, of course, have designed that system, that web application, which is now, as you see, potentially multiple instances or VMs around the world, and even cache copies at one of the content delivery like Cloudflare or somebody. And so we have to look at all aspects of that and decide, what do we need to protect against? We probably would want to use somebody like a content delivery network, CDN, like Cloudflare or somebody like that, because not only do they provide that additional ability so that, they're even closer to the endpoint. So you may have so many distributed copies of your application, and then they, of course, have pushed it out to their cache servers closer to the endpoints, your end users. And so many times they're going to be able to deliver that content from their own cache copy. And that's useful, less coming back to your instance in the cloud, and thus less cost in the cloud. And you can spread that out. You can get even faster responsiveness. You can build some redundancy into the fact that, if one of your nodes goes down, even though it's going to be slower, the European node goes down, well, we could have it set up very quickly or as failover, so that we could pull from one of the other, the American or Asian nodes, for example. So we're going to build in all of those things we've talked about. Security, obviously, from the beginning and get-go of, we're going to lock it down, we're going to harden our system, we're going to only have what we want running on it, we're going to make sure that ideally the only people we want, we're going to test it and everything else along the way as we move it forward. But we're also going to think through some of that. And beyond using a content delivery from the point of view of speedy delivery to our end users, they also provide a lot of neat services, including the protection against denial of service attack, because they've in effect helped to spread that information out. So there's a lot of things that we would take in. And, this would be the same thing as if you were setting up a data center. That's a big project and ultimately a complex system. So we're going to have to think of things like physical security. We're going to have to, if we feel like it's important enough that we're going to build our own data center and we're going to house information, it's probably information that we really like, customer data, very confidential data that we don't trust maybe to the cloud fully, or we just need our own control. We feel like we do in our, for our business and our needs. And so you end up, needing to actually do something like that. Well, once again, you would want to look at all aspects, all domains, all areas of that as you built it out, You would want to have security and redundancy built into your connections outside world. You would want to then, of course, have your own firewalls and routers as that connectivity comes into your data center. You would figure out how to layer your security with layers of intrusion detection and segmentation, etc. All the things we've been learning, and we would apply that all the way across, the entire network architecture, and as well as the building. We'd have to design the building securely. We'd want cameras and monitoring, and depending on how secure, man traps and biometric locks or whatever, but we would make sure we have those multiple layers of both physical and digital security to protect those assets. That, once again, is our core job in cybersecurity. There are, of course, a lot of, as I have my note to myself, more best practices, and many of them are common from previous areas. A lot of these, sort of, don't necessarily go into things without backup plans, think things through fully. And then, one of the things that I made a note for myself here is, like I said, really pay attention to that one example network. You're going to find in the lesson that you're given a diagram, and it's got some question marks and some links and some areas defined. And so you're just going to have to think it's not overly complex. I'm not looking for necessarily, specific brands, though I have had students recommend those before, and that's cool if you do the research or want to know. But we're really talking about types of devices, what needs to go where, so that we can set up some security in that context. So I don't want to say too much more, because it's actually not a very hard exercise if you don't overcomplicate it. So then moving into lesson 9, we talk about a concept called secure deployment. A secure deployment actually can apply in 2 ways. One is that most common, to be honest, that we see and have seen historically is the idea of deploying updates and patches and things like that, which is something obviously is very important, given that all the time we're finding new vulnerabilities, and all the time vendors are having to constantly put out new patches and updates, including the most recent Windows updates. That was, just came out, one of the recent patches here, and there's been articles all over the news about Microsoft confirms you really need to do this. If you're not on automatic updates, you need to, because this, whatever, I haven't had the time to dig into this specific one this time, but I know it can lead to a remote execution, remote command execution. And of course that could not be good if we can execute a command, mess up your machine, encrypt your machine, inject a virus or whatever. So we need to stay up to date, but we also have to balance that, with the enterprise and our needs. I always tell this story. It was something that happened to me. I learned this lesson, I'm getting old, 20 years ago or whatever. But at the place I worked, we had pretty much, we were a mid-sized company. We had a mix of Linux, mainly servers, a couple others, a Windows and a Mac server. We had Macs and we had PCs. And so we had everything in our organization. And we had a pretty good setup where, and especially say from the design marketing side of the company, a salesperson could, submit an order. A graphics artist would then knock up, whatever it was, a marketing slick, a banner, a billboard, advertise, whatever, they design it, lay it out, give a draft, prepare that usually as a PDF, for that flyer or that promo piece, and then send it, be able to put it onto one of our shared servers, and in a job file organized kind of way, job number, and then the person who was responsible for that account could grab that, attach it to an email, send it to their client. They got some comments back on it. They would put that back in the folder. We really had a pretty smooth system, and we had smooth communication and information exchange and file exchange and everything between Macs and PC and Linux machines. And we were very happy with our arrangement. And then one day I come into the office and everybody's in a tizzy because it seems like half the network can't talk to the other half of the network. And what it turned out ultimately to be, long story short, is that Microsoft had pushed a patch out to fix a bug that they had discovered in their implementation of SMB, Server Message Block Protocol. Well, Server Message Block Protocol is a common sort of like protocol we use within, say, throw a couple Windows machines onto a switch and you start just sharing with each other, peer to peer. That's usually going to be what we're using, SMB, sort of network neighborhood back in the day, if you remember how they used to label it in like your file manager, file explorer, or just network now, that all those machines that can see each other on the local network, even if you didn't have TCP/IP, they could still potentially see each other, right? And Samba, which is basically a Linux open source implementation of the SMB protocol that can be used on Linux and Mac, allows those machines to talk the SMB protocol. And so we were using that mechanism, basically SMB, to talk to that common server in the middle. And when the day, overnight, patch day, yay, all the machines had been, new patch applied, rebooted, everybody comes in, logs in, and now none of the Windows machines can connect because we were using basically a Samba server, not a Windows server, for that interchange piece, because we wanted the Macs to be able to come in and talk as well and make it very convenient in a shared environment. And it worked beautifully for us, except that this fix for SMB broke our ability to talk back to Samba, back to the Linux server we were using as the linchpin of the operation. The server was fine. The Macs could still see everything fine. And, through a little bit of a process of elimination and running around for a couple hours that morning, what in the heck's going on, doing classic troubleshooting, checking a few machines, and do they have an IP, can they ping? And of course, we could do all that things. We could even SSH into that server. So it was not an internet connectivity. It was specific to the file sharing. And sure enough, a little research, and that was this SMB patch. And as soon as we, rolled that patch back, uninstalled it on every machine, boom, everybody was back. Now we, of course, were now exposed to whatever theoretical vulnerability was in that. And I say theoretical because there was a vulnerability, but it actually, when we looked at it, it's one of the reasons we rolled it back. We would have rolled it back anyway because we had to get back up and working. Then we'd have figured out what to do. And if we did needed to, we could have, potentially done something more creative to try to isolate or wrap that traffic. But there was not one of these cases, and it's kind of the way it is with Samba and SMB. It's not something that can generally be done over the internet or something. Somebody can't come in all the way across because Samba is a non-routing protocol. It talks in a local network segment. And so it's one of the reasons we segment VLANs, for example, is to keep Samba and to keep SMB from propagating out to other places, so that the accounting machines can't just see the sales machines, or vice versa. HR, they can't all see each other just by going and looking in the network per se. And we can isolate some of that, away. And this is, of course, a common way that viruses will spread, is to get on one machine and then use any weakness in Samba to spread locally from one machine to the next. So yes, we had, by rolling back, enabled our operation again, but we were, theoretically exposed to that vulnerability if it had gotten in. We felt at the time it had to be done, one, to get us back up and running, and two, we analyzed the risk to us that it was fairly unlikely. We actually had a very good, it was one of the things I was most proud of that group, that we really had, both through good security awareness training and a little bit of, in some cases, some of the people who weren't as knowledgeable were just kind of a little afraid of what we in the tech department knew. They were afraid we were monitoring everything they watched. And while that's technically possible, and some corporations do that, we weren't doing that. But we didn't disabuse our users of believing that we were constantly watching everything. So it kind of kept everybody in a way, kind of a little fearful. But that was cool in a way in that context, because it wasn't they were scared of us. They were just scared of, doing something. And so that was good, though, because they wouldn't click that link. They would call one of our techs. They would, forward that email. They would come talk. And we had pretty regular training. Anytime there was a known, we were quick to send that out, and say, hey, there's this kind of email going around. And we actually had pretty good, at the time, for the day, we were using a dedicated hardware device from a company called Barracuda, their FAM firewall, and some other layers. So we felt like we were pretty safe. We didn't let many spammy, virusy attachment kind of things come through at all, because we were pretty good at filtering. We had trained our system for years, and it cut spam for our customers and ourselves down drastically. And so, it's an ongoing thing. It's what I've done with my own group now. So I feel pretty confident that, and then we just kind of went around, everybody and said, okay, you're already great. Everybody's good. We just had a training last month about this, but just to reinforce, because we've had to do this, don't click on anything. Don't do anything, please, please, please. Because right now, if something got in, they could use that vulnerability to spread like wildfire around our network. And so thankfully, of course, we were able to roll back for a while. We did not have anything happen like that to get in. And then, of course, Microsoft patched the patch, and ultimately things went back to working, and we get up. But what this led to was, in our organization, that was a huge thing. We sat back and kind of did a post-mortem on that, and like you should, sort of after events. This was an incident. Like if you remember back at the end of lesson 10 in security foundations, this was an incident. We had to respond. So our incident response team kicked in. We tried to deal with what was going on. We fixed it. And then, of course, we sort of have those lessons learned. And we kind of, once we got everything, up and running that day, and then ultimately a few days later, fully back on track and up to date again. And we kind of sat down and talked about it amongst our team. And we kind of did some back of the paper, back of a napkin kind of calculations, back of a pad, just, wow, that probably cost us this much money, right? Because, and we did that analysis because that's what you do. You're trying to plan, right? With the whole business analysis and disaster recovery, et cetera. You've got to determine how long are you willing to be down? How long can you be down? How long are you willing? How much toleration? What is your goal to get back up and running? And of course, we were able to do it in a matter of hours, but those hours, did have a number of impact. We were not able to move certain jobs as fast. We thankfully did not feel that we had lost any job from that. But we had delayed jobs that now weren't going to potentially ship, and that meant cash flow. So there was a cost there that we were going to not get paid till a little later, not finish a job till a little later. Thankfully, not missing any deadlines or anything. But we also had to throw, a lot of IT manpower at it, extra time trying to deal with this. And so we start to look at that one. Okay, this was because we're trying to be good on security, and we got a balance here. So what do we do? So we ended up coming up with, and it's not uncommon. This is a very common thing out there, especially in larger organizations. We, in our case, had basically, it wasn't quite a spare, but they were kind of, and we had a spare extra, both Windows desktop client and a Mac. And that was because occasionally we would need to let something render, or, just some other, we were maybe compressing some monster archive somebody sent to us for a project. And so we would use those machines for those types of tasks. And of course, if we brought in a temp, whatever the case may be, we occasionally even had to bring, for a big project, maybe in Austin, we would bring one of our other designers in from one of our other facilities to come help for a period. So we kind of had this capacity there. And so what we did is we made a decision as part of our organization that we went around at that time and we turned off automatic updates. And the first thing you might think is, what the heck? Well, we didn't stop updating. We just put a little pause in it. And what we did was we left those two machines back in the back that had, sometimes other tasks, but most of the time, a good part of the time, we're kind of idle and definitely were perfect for this role. And we left them on automatic update. And then of course, whenever Mac pushed out an update, or whenever Windows pushed out an update, then we would see that happen on those machines. We were tracking the update schedules online, and then as soon as that happened, we would run a battery of tests on those machines to make sure, could they still access that file server? Could they still access the font server? Could they access the email? Could they do X, Y, and Z? Could all this stuff happen? And it was actually, we just scripted it all up. And it would try to log in here and copy a file there and do this and that there. And if the script ran successfully without errors, then okay, cool. Nothing in this update screwed anything up in our environment. And we would run around, we would push the update out at that point. And so, through a managed process. And then you'll even see in larger organizations, because, okay, yeah, sure, we have a few tests. So we're going to deploy something, this update. We're going to test it before we just send it out to 10,000 machines. But, testing it on one or two might not be enough. Machines, even in the same family, even if every company, every PC in your organization was a Dell, if they had not been bought, even then, to be honest, but if they're bought over time, you can go look. Dell, has a certain line of computer, And maybe in the first iteration of the Dell Latitude or Dell Desktop or whatever the hell, then it had, these components. But then, 6 months later, they've changed things. It's still the same chip and RAM, but one of the motherboard chips has changed. One of the, audio chips has changed, whatever. And then they would do that again. And so you would end up seeing that even the exact same computers, ostensibly same make and models, over time, they might be slightly different. And so because of that, and of course, definitely over time, a longer time, you buy a different make. And so you may have all Dells or all HPs or whatever you have, or even more, you have a mix of all kinds. So testing on one machine, one Mac, one PC might not be enough. You want to do that. It's better than not doing any testing. But what you'll see then is many times organizations will do what's called a rolling rollout. So instead of just saying, okay, fine, let's, now that we passed this test, our test machines took the update with no problem. So let's go ahead and push it out to 10,000. No, they'll start pushing it out to, say, a department at a time. And not to throw disparagement, it probably wouldn't be sales in a sales organization, but certain departments, not that they're not critical in the long-term success of a company, or they wouldn't be part of the organization, but to some degree, some would be less impactful in the short run if they are down. And that can vary by the company, but no throwing no shade. My wife's been in HR before, but if I had a choice, I might push out to the HR department. If the HR departments, if that patch rolls out and half those machines don't work and we're going to have to roll back, well, they're going to be upset and they're going to get a little behind. And of course, I wouldn't do it probably when payroll is being processed, but almost any other day of the week, they're dealing with standard things and reporting and HR complaints and paperwork and sick days and vacation, and that's all important for the running of the organization. But at the end of the day, if we pushed out our patch to them and it took half of HR down for that one day, we can fix that. We can roll that back. We can then realize we're not going to push it to the rest of the company, but that is going to be inconvenient. Somebody's vacation would have to be kind of manually. Yeah, look, I couldn't file it through the website because your systems were down, but I'm telling my boss and they've agreed, and we would work it out, and people would get their day off. And if they took a sick day, we would get it updated in the system tomorrow when we got things fixed. But we wouldn't want to roll that kind of a patch that half the computers out there, because it could be one of those model things. We tested on a Dell and a Mac. We push it out to the whole company. The Macs are fine. All the Dells are fine. All the HPs go down. And so we might want to use sort of a staged rolling deployment. And it's very common. Plus also just for practicality, do you want to push out, even if nothing goes wrong? Do you want to push out a major set of patches to machines in a live mode while people are working? It's possible, once again, certain departments in marketing, HR, certain things that are not, once again, not disparaging. I'm just saying that they're instantaneous. If they're down a little bit, if we tested on them in a sense, then the impact is less than if we take our sales department down or our production department down. You see where I'm going? So we would want to, sort of stage this out. And I've even seen this sadly be done wrong, funny enough, by Dell. I was trying to make a pitch one time years ago to build a web education solution, which I ultimately did for Dell. But I had come in and, was meeting with this lady who was the project manager, and I was going to show her a prototype of this web education solution that we wanted to build for a particular need they had there. And we had made it to the short list, and this was a big kind of make or break moment. And I tell her what URL to go up to, and her browser takes 3 or 4 minutes to launch. And we're like, what? No. And she's like, I don't know what's going on. Then she looks down and looks at one of those little hidden icons in the corner kind of thing, right? Basically, it probably wasn't meant to happen because this is prime time work, but maybe it's the way it worked and they hadn't planned it very well. But they were pushing a big update to all the machines in her department. And so all these machines within that same segment were getting pushed a bunch of, megabytes of data for this patch. And so obviously that local segment was kind of flooded with all of this. It's like all of them were downloading simultaneously. They weren't, they was being pushed, but the effect is the same. And then her machine was running slow, her internet was running slow. So, once we finally got the browser to come up, then it was taking way too long to try to go through all that, fight through all that bandwidth congestion to pull my site. Thankfully, I'm usually very well prepared. In that case, I had a USB stick that had, a version of the site that I could just say, okay, hang on, let me plug this in. We'll go file open. We'll open this up and you can take a look at it right here. Thankfully, that was able, and that type prototype would run that way and would run locally. But that's sort of my whole point. You've got to take into account the impact of pushing out updates, and more what we're seeing is, of course, a lot of companies are becoming software companies. So this goes beyond just patching. This goes beyond to putting out your own software, and this, of course, very much includes your own website. They're pretty elaborate applications. You want to go through a series of steps before you just push out a big change, right? And a lot of companies these days have apps that are part of their corporate offering. They may have apps that customers never see. They're internal. They're for the employees, but they're built in-house. Some development team has built them. And so the other side of secure deployment really kind of goes to software development. And we'll see a little bit more of this discussed at kind of a higher level, or kind of come back to it in both the programming class later in when we talk about something called unit testing and how that's important. It's a part of this in the big picture. We'll see it again later as well in some other parts of the program. But in this case, what you're seeing is usually you'll find that most organizations, and it can vary, but 3 to 4 steps are involved. There'll be a development step, the dev step. Okay, so a developer or developers work on whatever it is, the website, an application, a custom client server application, a web app, a mobile app, whatever it is, anything that they're building. And like I said, this can be for internal or external. It could be for your customers, or it could be for your staff. It's not uncommon. And in many cases, organizations, we're becoming more and more software companies. And so the ideal model is that the devs will do their work. There'll be a development phase. And ideally, they're doing testing themselves, right? They're checking their own code. They're running tests against it. We can even in cybersecurity help drive some of that. Looking, hey, make sure you do test. Are you sanitizing your inputs? Are you checking to make sure there's nothing that could get through that could cause an injection kind of attack? And you'll see and understand that even more as you get to play with some of that in some of the coming classes and actually exploit some of that. And so those are obviously the things we want to make sure our devs don't do, so that nobody else can do that to us. So we try to have the devs still be guided. Maybe some of their testing, unit testing, if you will, testing of their own code is incorporating some of those types of things for us. But then there's a testing phase. So we'll put that up to a testing environment. In some cases, if that is this is where you usually see the 2 to 3 steps. Some people go straight to a testing environment that's also close to a staging environment. In other companies, we'll break it into 4 steps. So if you see a combination, it'll usually be the middle 2 combo. So we'd have dev, test and stage, production, or we have dev, testing, staging, and production. So what is the difference? Well, if you're going to break it up, testing can be on like a small, just a server there in the dev department, maybe internal, maybe it's on a particular cloud instance where you throw it up, spin it up, test it, beat on it a little bit, and then you take it back down. And of course, there's an iterative cycle here. So we do dev, we move into testing. If the testing's good, then we may move to the next step. If not, we're kicking it back to dev, and then we'll do this. And so then what is the difference between testing and staging? Well, like I said, they can be combined. It depends on the deployment model, how complex of the application in question. But in many cases, if you break it, like I said, the testing server, that first phase of testing is really doesn't have to be exactly like what it's going to be out there on the, it can be an internal knockout, maybe you're going to deploy it to containers in the cloud, but you have a little web server in the office, and we throw it over there and we run our tests, security team, everybody, DevOps, everybody's taking a look at it. Other programmers taking a look at it. We try to run it. We got our Q&A people, our testers, take a look at it. And if it passes, then we move on. The staging, if we're going to stage, most companies will have an environment that is very similar to the live environment. So if the live environment is an Ubuntu server lockdown, running SSH for access, running a Nindex web server, running whatever database, and that's what it runs, and that's what's going to power our application. Then we're going to have set up, up in the wherever it's on our own server, in our data center, in the cloud. But that's our environment. That's the final environment. Then we want to set up an environment that's very close to that, so that we can, once again, we can stage it ready to take it live, and we can also do more testing. But that's why sometimes you'll see that combined, is some people won't do an extra step of testing on, say, a throwaway box or something. They'll just go straight, in a sense, to staging, and they'll do the major testing and staging prepping all together. And if it passes that step, then it's ready for production. If not, then we're back to the devs and we rock through this again. And so you can see, really, we have sort of that model as well. Whether it's patches, we want to test it. The dev step happens, by the way. It's just not us. So like if Microsoft's devs put out a patch, that's the dev step. We're then going to test it, not just roll it out globally. And then we may want to stage in our own way, roll out that as continuing testing. Now we're pushing it into live production, but not everywhere. Same model here, except we're doing the dev. Our dev team built the stuff. Now we have to do that testing, and then we have to make sure it's ready to go into live production. And if it passes those steps, which I said can be 3 or 4, depending on how you break it out, and different teams will, this will allow it to finally then, feel like when you take it live, you've already checked it for, bugs and things like that. You've checked it for injection and possible vulnerabilities. You've checked it for suitability, that it does run on the real live environment, because your staging environment is very similar to your final production environment. And then ultimately you deploy and go live on the production servers or production VMs or instances. So it's a pretty common model, and it can apply either way. It can apply to just the patching, because if you break it down, like I said, the dev part still happens. It's just a third party does it for us. But we still want to, we want to test that and then roll that out within our organization if it's our own. So it's very important concepts. And one of the things that, it's at that testing stage primarily where we in cybersecurity are going to have a fairly big role. Yeah, there's going to be QA testers that are testing to make sure the app works and that the UI is pretty and there aren't any spelled words, but that's not our business. At our point, we're going to be in potentially testing that web application, that software application, that mobile application, whatever it is that our dev team's written. We need to poke on it. We need to prod it. We need to spin up and fire off some, some vulnerability scanners against it. And it's basically what you're going to start to learn in pretty good detail in the very next class as we move on. All the tools that we might, a sampling of the breadth and depth of tools that we might use in the stage, depending upon the application in question. For example, you're going to learn about different types of scanners that can do vulnerability assessments, including specific web-based scanners. So if it's a web app, let's scan this sucker and see if there's any problems. If somehow through their own dev and self-testing and even their other testers, no one's figured out, that, oh, look, they're not checking this field thing and making sure only the values they're looking for are accepted, and we can inject something else in, then we're going to try to see if we can pass in a SQL statement to talk to the database, maybe pass in a command to talk to the file system. And if that, injection is there, then obviously we're going to be the ones who fail and send it back to the dev phase. So you're going to see that, and it's actually becoming more and more common. I've seen this. It's something that I expect to see in the next year or two, probably maybe even become its own kind of role. But I have seen it out there. But there's this concept of kind of a hot market is DevOps. And so what is DevOps? Maybe you've heard that term. Well, it fits into this. So DevOps people are usually system admin people. So it kind of fits into this perfectly. That their focus is not the general network, the printers and the users out there and the rest of the company. They're dedicated to the needs of the dev team. So they run their systems and they manage them. If there are servers, they're going to be the ones set them up, and they're going to do things, and they're going to take, work with that dev team. And in many cases today, one of the things that's happening, especially with the, with the cloud, is that one of the common problems in the past with development is that it was hard to keep all of your developers on exactly the same environment. Once again, okay, they're all on Windows, they're all using Visual Studio because they're, if they're writing Windows apps, or they're all using whatever. And well, that person's on a Mac, that person's on Windows, doesn't matter, we're doing Node. Well, it can actually. And just to make sure, one of the things that we see a lot many times in development today, a DevOps engineer is using automation and scripting, like we've learned the basic to in the cloud, to spin up a virtual machine or an instance, and all the developers that are working on that can use it to test their app and write their code and work in. And then we absolutely know that every developer, whether that's being done through SSH or remote desktop or whatever the methodology, full VMs or containers, it's 6 of one, half dozen another. At the end of the day, we're controlling what we spin up so that every developer is basically working in the exact same environment. So we eliminate the possibility that, some weird little variant in the underlying, system, whatever that is, Python, Node, Ruby, it doesn't matter. Whatever that underlying language, there's a slight difference, the way something happens on one platform versus the other. And so, it works fine for Bill on his Mac, and Sally's got her code working fine on her Windows machine. They check it in the GitHub, test each other's code, and neither one of them works. Well, we don't really like that. Let's make sure they're all working on the exact same environment. And so DevOps is a really popularly growing role for system admins to focus on. So if they learn a little bit about dev, understand what programmers do, and I really think we're going to see a secure DevOps role. I mean, it is there, but I mean more of it, like it grow almost to its own little niche, because that's the perfect time to inject security is in that process right there. We want to make sure, we want to help the programmers with their own self-testing, make sure they're checking for things that are common, that are known. Are they making sure that they're, cleaning up and checking and error correcting it on any input from the user, not trusting it? Are they using any third-party libraries? Are there any issues with those? And so we can, by sort of pushing down a cybersecurity person into the DevOps team, I think that's a growing area that we'll see more of. And it's, a very valuable place, because if we can nip it in the bud, so to speak, if we can help that dev team be write more secure code and help them, create self-test and unit test that they're going to run on their own code as they work on it to catch things. And then we're there at that initial testing stage, well before, especially if there is the fork, we're well before staging. We want to be testing it right then. And, so on that testing server, maybe even in-house, but we can pound away on it. Or we can have the other DevOps engineer spin us up a VM with a copy of the most recent code that we can go pound on, and then, do our own report. And once again, then maybe we'll make it to that next place where we're going to take it to the staging area and put it on more of a realistic environment. And yes, we're going to test it again there. We want to test, especially from a security point of view. And I've obviously in our program, I focus on security, but this is true all the way across. I mean, one of the worst things you can do actually is, everybody makes a mistake once in a while, but to really, mess up your website when you update, to mess up your application, and all of a sudden it breaks everything. If you let that kind of stuff get out there, that can be totally damaging to your company, right? You can lose a lot of customers. People are just like, forget this. It's causing my phone to crash. It goes black screen. It tells me it's not responding. Delete it, and they go on to something else. And now there's somebody else that's getting that business, not you. And of course, especially if you have any, kind of serious confidentiality there, you're a banking app. Oh my gosh, you sure don't want that broken, and you don't want it vulnerable, right? And so in some of those places, that's where you're already seeing what I'm talking about. These teams that are integrated teams, there's representatives in a way of not only system administrators, the sort of DevOps, but security, cybersecurity, web, pen testing, different things like that are part of now development teams to make sure as we go through these stages that we end up ultimately deploying something that's safe. So the last lesson I'm going to hit pretty quickly, because it's one that we touch on off and on, but it is what's kind of, and we'll come back to it again. It will be mentioned again in other courses later, but it's the whole concept of embedded systems and the Internet of Things. Now, one of the things I always like to explain to people is that when you really get down to it, the Internet of Things, as we call it today, is really just version 2 of embedded systems. The only big difference is that in the past, generally what we call embedded systems, you usually saw this on the manufacturing floor. You saw this in complex systems like cars, boats, planes. A perfect example that almost everyone can relate to is the anti-lock brakes in your car. That is an embedded system. When you stomp on your brakes, if you did it way back when I was a kid, you could lock your brakes and your car would slide. And you would lose control potentially. And so we were taught to not to do that, to actually pump our brakes, especially on, any kind of slippery surface or whatever. You just didn't want to do that. But everybody's reaction is just stomp on the brake when all of a sudden here's something crossing their path, right? So most cars today have anti-lock brakes, and you can stomp on the brakes all you want to, because the car, once you stomp on the brakes, it's using the amount of force to give it an idea of how fast you want to brake it. But the system, the computer there that's in there in the brakes, it's controlling it, and it does it. So it basically does this. It presses and stops, but lets go. So it never locks the brakes. I don't care if you put both feet and really stomp. You can't make that system lock the brakes, because that embedded system, that little computer, is going to apply force, and it's going to apply more and more, but it's never going to just lock, because it lets go. They're very small, sort of like our modern fighter jets. Some of these things are so advanced, so amazing, that they literally can't fly without their computers, because even though the fighter pilot's doing that, they're really kind of unstable. And if the plane wasn't making, itself, the avionics was making, adjustments to the rotors and the fins, the plane would not be stable. You could not fly it without those micro adjustments being made to balance out. But then, of course, it's let us build some amazing aircraft that can, push the envelope of what fighter planes and aircrafts can do. Cool stuff. That's embedded systems. Factory floors being driven, conveyor systems, logistic systems. Those are embedded. And so what did we do? We were putting computing power into a discrete thing. Your brakes, the avionics, the controllers of a plane, the factory floor. Cool stuff. So what is IoT? What is the Internet of Things? It's pretty much the same thing now, except for two key differences, because it really is the same. I really say it. Embedded systems and IoT are the same thing. But the two differences, really, when you get down to it, are this. In the IoT space, we're putting computing power into everything now. There's a commercial. It's an AT&T Wi-Fi commercial, but you see this family coming out and throwing all their smart devices away. And I can't even recognize all of them. There's phones, there's smart speakers, there's all kinds of stuff they're trying to go in the trash. And at the very end, the wife is dragging out the smart television, with the big 7-inch screen in it, with an Android tablet, built in basically. And the neighbor is saying, it's not your devices, it's your height. But the point is, there's all these devices now. We're putting smarts. We're embedding systems basically into refrigerators and dog collars and the baby cameras and the washing machines and faucets, microwaves, everything. So it's really just the same that we used to do, but now we're doing it everywhere, not in just specific industrial and complex systems. We're putting it in a dog collar. Nothing complex about a dog collar at all. But the other nuance that is different, that's a little different, is that we're almost always doing that with connectivity these days. So your Nest thermostat gets on your Wi-Fi and can talk to the cloud, and their system can learn you over time and help adjust it for you, right? Because it's using some AI in the cloud or something, right? We have the same thing. Your baby camera or your doorbell Ring monitor is going to connect to your Wi-Fi. It's going to talk back to the cloud, and you're going to be able to get an alert when somebody shows up at your front door, through an app or something. This is all enabled by this new modern Internet of Things, but really it's embedded systems with connectivity. And it's not like the other systems weren't connected. Your anti-lock brakes are tied into the electrical system. Obviously, the stuff that all the systems into a plane are very closely tied together and integrated together, and sort of networked together, so information can flow. If something's wrong and that thing's not working anymore, the pilot of that plane needs to know that part, that wing is not working quite right, or it's throwing some errors or whatever. So it was networked before. Even the factory floor, obviously, we needed to be able to control it. But the difference is that, like I said, it wasn't usually wirelessly connected. It was more connected by, some form of cabling, and what we would call an operational network, as opposed to just sort of our normal network, digital network. And many times in corporations, they're isolated from each other, and they today almost need to be, because those original embedded systems weren't built with security in mind for the most part. Just like today, the vast majority of all this stuff coming out as Internet of Things devices they are coming from more consumer product companies that are building these things and throwing in some processing power and some storage, usually maybe a Linux kernel and a little stripped down OS. And then you throw some functionality on it and you throw the thing out there and sell it. And, but have you built security into it from the beginning? Are the devices even updatable? And of course, many times it's really weird, but some of the things that people are using, and I'm not sure totally why, but I think it's because they just go back to, they want to make it as small as possible. So they go maybe to an older distro, an older kernel. Even if they don't go to an older one, those vulnerabilities we can find all the time. So if you build this device, you design it, and then it takes some time to get that through design, build a prototype, test it. Okay, let's take it off to manufacturing. We're going to build 1 million of them now. 6 months later, they're being sold all over the place. Well, within the time you designed it and put that on there, and now you started building this, there's already been a number of vulnerabilities possibly found in that OS that you're using or within the systems and services you're using. I mean, think of your home router. It's in its own way, it kind of was the first IoT device. It does more, it's a router, but you basically have a Linux kernel in there in most of them. They're running a web server that you log into to manage the router. And a lot of devices, they've just kind of broken it now. Like if you log into a web page to manage your Nest or use the app, but it's coming off the cloud. But these cameras, sometimes they talk to the cloud. I have a bunch of these cameras actually, and most of them have an HTTP interface, so you can locally connect to them. They're talking on basically an HTTP. You can turn a browser. I can do it in my house with any of the cameras I have. I can just put in their IP in the right port and put a browser, and I'll get a feed coming off that camera, which is kind of cool in my context because I've locked it down internal, and I have a monitoring system where I kind of like you see on TV with all my cams on one screen where I can see. But then they also do have connectivity, to a cloud app, so I can be outside of this house and still connect in. But all of these devices can be a real big risk, and the implications are wild. In the days of embedded and the SCADA, supervisory control acquisition and data acquisition, is what SCADA stands for. This is a controls protocol, a suite of methodology for talking with some of those embedded systems. SCADA doesn't have security built in at all. And, there have been numerous types of places where industrial controls, ICS, industrial control systems, SCADA type systems have been attacked. One of the most famous, and I believe we talked about it even earlier, but I believe it's mentioned in this class, is the Stuxnet, Stuxnet virus that was inflicted upon the Iranian centrifuges a number of years ago. And now a variant of that a couple years ago almost blew up a refinery in the Middle East. And we're just seeing that we're in this place where, we're in a world where physical harm could happen now. And I'm surprised it hasn't yet. I expect it will. And then we still haven't fixed that. We have all that out there, and a lot of that's very much risky and is having to be kind of wrapped with VPN or segmented or trying to protect it. But at some point, there's got to be a connection point so that the normal network can talk to that operational network and you can control it. So if somebody compromises this box, then they're in and they can tell your systems to do anything they want to. So there are variants of attacks that are targeting industrial controls, and the number of attacks that are going on, like one of the top, and funny enough, I saw this literally, I say this all the time, and I was so gratified. I was watching a brief piece discussion in the IoT Village at, or IoT Workshop Village, workshop at the Village at DEF CON. And one of the things that they mentioned was the same thing I always tell is that, and it kind of depends on which list you read, but within the top, I still think it's 3. I think he kind of hedged a little more than me and said top 5, but okay, we'll say top 5. Maybe that's safer. There's another one I haven't that's come out. But one of the top 5 all time denial of service attacks happened just a year or so ago. And it was because somebody took over millions of baby cameras and monitors and all this stuff and then used it to attack. And one of my favorite stories at the moment is, it's an IoT, is my favorite theft story, is the casino. There's some debate as to whether it was in Vegas. And I have somebody, when I was there and told the story, who told me that it was in Vegas and a particular hotel, which I will not name. But nonetheless, I've also read the story was in Macau, but it doesn't matter. A casino in one of the major gambling meccas of the world, Vegas or Macau, had their high roller list stolen from them through their fish tank. And that always, I love telling that in a presentation or a class, and I prefer it when I have an audience because I can see the looks on them like, what? How did they get ripped off through their fish tank? And it's really a simple story. They have a big saltwater aquarium at their entrance, very pretty apparently, and they hired a third-party firm to manage it. That third-party firm came in and stuck a device in there that could monitor the salinity and the pressure and everything else. It was great. They stuck it on the Wi-Fi, opened up basically somehow, either they got it opened or it just opened with universal plug and play maybe. It basically was available on the internet so that you could talk back and these guys could see if they needed to come deal with anything, you know. But they didn't change anything, default passwords. So hacker is trying to break in, finds this device, looks it up, default username and password. They're inside the network now, inside the firewall. It's a Linux machine, a kernel powering it, so they were able to then pivot and use some tools that they, and then they ultimately, took the data file out through the fish tank. So this is something that we have to be aware of. And the lesson ends up with a little bit more about some of the common attack vectors and vulnerabilities for these types of devices. But I'm running out of time today, and I want a quick break before my next workshop. So that's what we're going to wrap up. And so I think this class is in really good shape. And this is also, after some of the other scripting and others that are a little more technical challenging, this is kind of more on the downhill slide of this class. You should all be in pretty good shape to wrap up. Remember, tonight is a due date, and Sunday's the final due date. And then we'll get all of you into the network defense class next week. And I think you'll enjoy that one as well. If you have any questions, let me know. I will see you later.